right, it's about time. So we're going to go ahead and get started. Welcome, everyone. My name is Jessica. Hold on. My name is Jessica, and we're going to be talking about computer coding concepts today. In the chat, we also have Meredith, who will be keeping an eye on the chat and making sure that if anybody has questions, that they get voiced. While in the Zoom program, you can exit the full screen mode by using the escape key on your keyboard or by clicking the exit full screen on the top right of the screen. During this webinar, your camera and microphone are turned off. If you have any questions during the program, please type them into the chat. You can find the button for the chat box at the bottom of your screen. All right. Welcome to Computer Coding Concepts. In this class, we will be looking at the building blocks that go into a computer program. Knowing about these, you'll have a better idea of how programming works. And if you want to learn how to program, the concepts taught here should be applicable in most modern programming languages. The goal of this program is to just introduce the most common pieces that make up a computer program. A real computer program might use only some of these concepts or may use multiple of the same type, or the big ones have many, many combinations. Programmers mix and match based on what they need their program to do. This overview is not a full tutorial for creating a computer program. We'll be using Pseudocode, which is an intermediate step between human descriptions of what a program needs to do and the code the computer understands. That way, this code, you can look back on it, and as you work on learning a specific programming language, you can convert the steps that the pseudocode spells out into the code of the language that you need. A few things we'll be covering today. We're going to be covering the difference between languages that computers understand and human language, what exactly a programming language is, and some different languages that are in use today, variables and comparisons, making decisions, so different ways to make decisions within computer programs, loops, which is code that repeats until a condition is met, arrays, which are basically lists of variables, and then we'll touch briefly on object-oriented programming concepts like functions, methods, and classes at the end of this program, time permitting. As you can see, we are covering a lot of material in a small amount of time. So if you need to go back and review something, remember that the class recording will be posted on our YouTube channel later. We'll also connect you with some more resources for learning at the end of the presentation. So, human versus computer language. A computer program is a set of instructions that tells the computer what to do. But computers don't understand English or Spanish or Greek or any spoken human language. To make a list of instructions that the computer understands, the programmer must use specific keywords, phrases, and punctuation to make sure that their program is understandable to the machine. Computers also can't understand instructions unless all of the steps are spelled out. For example, if you tell a guest who's just had dinner with you to put their dishes in the sink, a human knows that they must stand up and go to the kitchen sink. They have to walk and go over to the kitchen. A computer, if it isn't told that it needs to stand up and walk over, it might get stuck and do nothing, or it might just start throwing the dishes across the room. Because the instructions must go step by step, programmers will often use pseudocode as an intermediate step between how a person would explain the instructions to another person and how the machine needs to be told. What pseudocode is basically a computer program written so humans rather than a computer can understand it. We use it to break down the steps of how a program is supposed to work before starting a program. Using the pseudocode helps the programmer find missing steps and makes creating the final program much easier because those steps are happening in an earlier phase rather than after they're already made into the program. Pseudocode is usually easier for humans to read and understand and breaks down the steps or logic that the computer needs to do the work. It saves time because it prevents missteps. And it also can make it easier for multiple people to work on the same programming project at the same time. Because each step is spelled out, it's easier to delegate some steps to other people without having to do a bunch of work later to make all the pieces fit together. Then the pseudocode can be converted into whatever programming languages the programmer wants. Examples in this presentation will be in pseudocode to make it an easy reference, regardless of what programming language you want to work with, though. All the examples in because all of the following examples are actually pseudocode, they're not going to be following the syntax or grammar rules of any specific language. So that'll be something to pay attention to if you decide to convert it into an actual program. But they will use the same logics and steps. Now, we've talked a lot about pseudocode. Let's talk about some programming languages. Programming languages are basically ways of writing a computer program. They are sets of rules for writing programs. Each programming language has its own rules that must be followed for a program to work. Different instructions may need to be ordered in a specific way, different punctuation marks may need to be used, etc. There are dozens of programming languages that are in use today, but some common ones are the C, C++, and C#, which is just generally referred to as the C family of programming languages. There are also more modern ones like Java, Python, and Ruby, which are all relatively new and fairly popular. There are also some older programming languages like Prolog, COBOL, and more. For older programming languages, there aren't necessarily a ton of new programs that are being made with it, but there are older programs that are still being used and maintained, which means that those languages do still come up. There are jobs that use those older languages. There are many, many, many other languages out there that are not listed here. This is just a sample. All right. Are there any questions so far before we get into all the bits and pieces?
None at this time.
All right. Okay. We'll move on to variables and comparing. There we go. So variables are words in a program that can represent data or information, kind of like the x in an algebra equation. Variables make it so that code can be reused with different information. For example, if a program asks you for a number between 1 and 10, a variable will allow you to type 9. The program will save that 9 into the variable, and then that can be used by the rest of the program. This makes it so the programmer does not need to write the program 10 different ways for each of the possible inputs you gave it. Variables can initially be empty or uninitialized, or they can be initialized and give an initial starting value. They almost always can only store one data type. Data types are just the type of information that that variable expects to have stored in it. Some examples are in that blue box on the side. Integers, which are whole numbers. Doubles or floats, which is same word for different sizes of decimal numbers. Strings, which is words or sentences. Booleans, which is just a true or false value. And then characters, which would be usually a single letter, but can also be things like Sometimes the format might be a little odd depending on the language, but things like parentheses and stuff like that. The computer will treat all of these differently. So the variable needs to know what type of information it's going to hold. When you are setting up variables in your code, it is a good idea to name the variable something that tells you about what data is stored there. For example, you could name a variable number, but that doesn't explain very much. It could be a phone number, a barcode, or the number of times you stubbed your toe this weekend. Number of cats almost definitely holds an amount of cats that the program is working with. So on the side there in that blue box again, we have integer with the whole number 127. The double 127.002 is a decimal point. Also, even if there was no 2 at that end, if it was just 0.00, it would still be a double because it has a decimal in it. And then Boolean just holds true or false. Character just holds the character A. To make a variable without a value in it, you usually can just end the line of code after the variable's name. A single equal sign is what ties the variable to what is stored in it. Depending on what programming language someone is programming in, letter cases may be important. So all lowercase cost and capitalized cost may be different things. Usually the convention is that variable names start lowercase and don't have spaces in them. Using variable names that clearly say what they do helps keep the code organized, flexible, and easy to understand for both the original programmer and for anyone else who needs to look at the code and figure out what it does. All right. And then we have some more examples of different integer initializations below the blue box. So number of puppies would be an integer and it stores the whole number 4. Double cost equals 27.99. And then last initial, if it was just an H, you wouldn't really know, like, why is there an H here? Because we said last initial, oh, it's the initial for someone's name. Okay, now that you have variables, you can compare them using comparators. Comparators are just the greater than, less than, equal to, greater than or equal to. They're usually written over like they are in that blue box there because there isn't a greater than or equal to sign on your keyboard. Also, you'll notice that the equals, if you're checking to see if something is equal, you use 2 equal signs stuck together because the single equal sign, if you remember from the last slide, assigns the value to that variable. If you were trying to see if a variable is equal to 10, but you only put 1 equal sign, then you set it equal to 10 on accident, and that makes it true all the time. You can also combine the comparators using and or. The result is either going to be true or false. So on the next slide, we have some examples to help explain that. So we have 5 is greater than 3, which is a true statement. So that comes out to true. 3 is less than 1 is false. So that answer is false. Now, if we put those two together with an and, 5 is greater than 3 and 3 is less than 1, that's not right. That's false. Because if you have a false in an and, then it becomes false. But if you were instead to or, 5 is greater than 3 or 3 is less than 1, then it becomes true because one of those is true. And then if you or those two statements together, we determined in the third and fourth line that it was false and true for those. So if you have a true and a false, you have true and false or true or false, which simplifies to false or true, which becomes true. Which I'm sure wasn't confusing at all. If you have any questions, please let me know. Okay. Did we have any questions so far?
Not yet.
All right. I hope that means I'm making sense. All right. Next, we're going to look at making decisions. Because the computer is running through what to it is a list of instructions, it needs to have some sort of mechanism to make a decision. Comparisons, which we just looked at, allow lines of code to be executed conditionally by using an if statement. An if statement sets up a comparison, and then if that comparison is true, then a set of instructions will be followed. Otherwise, they're skipped. This allows segments of the code to be optional instead of just one big list of instructions. You're also able to put a Boolean in the if statement, and it will work since the Boolean is just a true or false value. You can also put a number in it, and if it's any number other than 0, it'll be true. And then with 0, it's false. Now we have another example to run through. So if we say that the variable cookies contains a number, and then the variable cupcakes is a Boolean, so it can only be true or false. So if the number of cookies is greater than 2, then the instruction we're going to give it is to print, I have cookies. If the number of cookies is equal to 0, then it prints I'm out of cookies. If the variable cookies equals 1 or 2, you eat the cookies and set the amount of cookies to 0 because they've been consumed. And then because cupcakes is a Boolean, you can just go if cupcakes, and then if it's true, it'll print I have cupcakes, and if it's false, it will print nothing. These are all separate if statements, so they don't have any effect on the one before or after it. The way that they're set up, there isn't any overlap, but if we change the first one to greater than or equal to 2, then if there are 2 cookies, then the program will run through that first statement and print it has cookies. And then because it also satisfies equals 1 or 2, it will then eat the cookies. So it will announce that there are cookies and then it will eat them. All right. There is also an extended version of if statements, which is if-else statements. Before, if the if statement was true, then it would do it, and then it would just move on. But you can put an else adding after the if statement. If you don't put an else, by default, nothing happens, but you can fill that else space with an additional instruction. That would happen if the statement is not true. Following the last example, if cookies is greater than 2, we're printing I have cookies. Or else, if cookies equals to 0, print I have no cookies. Else, eat the cookies, set cookies to 0. Jumped a bit ahead of myself. You can stack if-else statements on top of each other, which means that it just checks through the if statements one at a time to see if it's true. And once it finds a true one, it will execute what's underneath it. But as long as that if is false, it will keep going to the else. So you can make long lists of these if you want. That said, with a chained if-else, it will only execute one instruction. Before, we just had the if statements on top of each other, and if any of them overlapped, they would be able to be, both things would be able to go. But if it's an if-else statement, especially an if-else stacked statement, it will find the first one that is correct, and then it will move on. It will skip the rest. If you want to make an if-else chain do more than one thing, and what you probably actually need is a switch case. A switch case considers one variable, and then based on that variable takes an action. In general, it only takes the condition that matches first, but depending on the programming languages, you can change how, if they flow into each other or if they break. If none of the cases that are set out in the switch case are true, then the bottom default option is the one that it uses. Many modern programming languages have some version of a switch case, but older languages may not. And each programming language would format their switch case a different way. So if you decide to use a switch case, you definitely want to look at a guide for whatever programming language you're learning to make sure that you set them up correctly and find out what variations on the functionality you can do. Okay. Any questions about making decisions?
None at this time.
All right. Next, we're going to go into loops. Loops are parts of a program that repeat. That means if you want something to happen 10 times, the programmer doesn't have to type it out 10 separate times. They can just make it once and then put it in a loop that they know will run a certain number of times or until a condition is met. There are 3 kinds of loops: while loops, do while loops, and for loops. While loops only run if the condition is met. Do while loops are guaranteed to run at least once, and for loops are the most complicated to set up, but are very good for letting the programmer decide exactly how many times something is going to run. Important thing to note about loops is they will go on forever if a programmer lets them. Something in the loop must change the condition the loop is based on, or the program has an infinite loop. If there's no way out, the program might crash or need to be restarted, which is usually not what the program is supposed to do. Also, you can put loops inside of each other. You can mix and match the loops. You can have a loop inside of a loop inside of a loop. They are very flexible. We are going to discuss each of those 3 loops in a little bit more detail. While loops are the simplest type of loop. They start very similar to the if statement in that you have the name of this building block, while, and then a condition afterwards. A comparison. If the condition isn't met, or if the comparison returns a false, then the loop is totally skipped. If the condition is met, then the loop will run until the condition isn't met. The code that is contained in the loop needs to change the variable involved in the condition, or it will keep looping forever, because the condition will always be met unless you change how that variable works. So in the example here, we're looking at cookies again. There are cookies. We're going to say there's 2 cookies. 2 cookies is greater than 0. So we're going to print, you ate a cookie, and then we're going to subtract 1 from the cookies. Now that we've run through the code once, because we subtracted 1, cookies is now 1. 1 is still greater than 0. So once again, we print, you ate a cookie, and then we subtract 1 more from cookie. After that second loop, cookies is now 0, which means that is no longer greater than 0, and the loop breaks, and it's done. You can, hold on. Yes, okay. For do while loops, which are very similar, they always run at least once though. It starts with that do, then it contains the things that happen in the loop, and then at the bottom we have that same while and the condition statement. So in this example, do give cookies to a friend. So no matter what the value of cookie is, we are giving one away and we are subtracting one from cookies. And then if there is, at the end of that, if there is still cookies more than one, then it will go through the loop again. This means that if the initial value of the cookies is 1, then you give the cookie away, subtract 1, so now you have 0 cookies, and then it's over. It's only run the one time. It also means that if the value of cookies is 0, initially, you somehow give your friend a cookie that you don't have, and you have -1 cookies, which I guess means you owe your friend a cookie. All right. And then for loops. For loops are newer than while and do while loops. So not all programming languages will support them, but a lot of newer ones do because they are quite useful, especially when we get to talking about arrays later. But the way a for loop works is it starts with a for, just like the other 2 loops, it has its name. And then it has 3 different parts inside the parentheses, 3 different parts after that for. The first part makes or initializes a variable. This is like the one time where you don't need to be terribly descriptive with your variable name because it only works inside the for loop. And so it's only going to need to be accessed in this very small piece of code. And you know exactly what it's doing because it's in the initialization for the for loop. So a lot of people just call it I because it's easy to type. So we have that variable. Then it has a condition like the other loops. Usually the for loop condition involves the variable that was just initialized. And then at the end, it has a part that updates the variable. Usually this will be adding or subtracting by 1 or 2. For loops are great for making a loop run exactly the number of times the programmer wants it to run. Can be if the same message needs to be printed multiple times, or following our previous examples, if you know for sure there are 20 people who need cookies, you can just pass out enough to give 1 or 2 to everyone and then keep the rest for yourself. That would let the way to exit the loop be the number of people as opposed to the number of cookies. And then once it's gone through the for loop a certain number of times, it will automatically exit instead of waiting until cookies drop down to like 0 again. Okay, are there any questions about loops?
None at this time.
Right. That means we get to talk about arrays next. Arrays are collections or lists of variables. It's listed in order, and then all the variables stored in the array can be referenced with the name of the array, plus the number to indicate its spot in the list, or the variable's number in the order. This is great for lists of things that all have very that would all have very similar variable names, like say the list of friends who we've been giving cookies to. Instead of 20 people who all have a different variable name that has to be remembered to make sure a cookie is given to them, they could all be in an array named friend names, and then friend names 1 could be Frank or Sarah, etc. That said, the first item in an array is referenced with a 0 instead of a 1. This is because computer numbers start their counting at 0. The largest value that refers to a variable in the array would be the number of items in the array minus 1. So if there are 7 people in an array, they would be referenced as 0 through 6, and then friends named 7 would be actually referring to the whole array. Okay, so we have a couple of example initializations for arrays down here. So we have an array of integers called classmates. And there are 7 classmates on that list, but they would be listed as classmates 0 through 6. Classmates 7 is usually only really seen during the initialization. And then classmates 2 refer to the 3rd classmate in the list. And just to make sure we have some more examples. Say the array class attendance holds a list of the number of people who showed up to a class. The array is 10 numbers long, and they're named from 0 through 9. So class attendance number 3, where's my mouse, is 20. Class attendance number 0 is 12, because for 3, we counted to spot number 3, it's 20. At 0, which is the first one, it's 12. Class attendance 9, which is at the very end, is 18. So you see we started at the 0 and we just count up normally, but there is no 10 in class attendance 10 because that was just how we told it how big it was going to be. In most programming languages, arrays can only contain items of one data type, like integers or strings. They also can't store multiple things together. So if you wanted to say Frank was a classmate, so you have his name and you also want his ID attached to him as well. They can't go together in the same array if it's in a list, if it's a list of names. They wouldn't be able to be stored as separate variables. You would need something a little bit more complex than an array. It is possible to put an array inside of an array. That is called a nested array or two-dimensional array. It's also possible to have an array inside of an array inside of an array, which is a three-dimensional array. Past that point, it gets really complicated to keep track of and also takes up a lot of storage space on the computer. So generally, there are better options beyond the, you wouldn't want to make anything bigger than a three-dimensional array. Okay. All right, and we have a question here. I see the chat has popped up. Okay. All right, do we have any other questions, guys? Okay.
None at this time.
Okay. And we're going to briefly look at object-oriented programming. Oh, my bad. We're going to go over putting it all together type situation. So we have that class attendance 10 again with that same list that we had earlier. We're also going to make a variable called total odd and set it to 0. We're going to say total odd is the total of the odd number of classes. So every other class, we're going to add it up. Then we have a for loop here, which sets up an integer, a counter, sets up a variable called count and sets it to 0. The condition is count while count is less than 10. And then when it reaches the end of the loop, it will increase count by 2. And each time it goes through the loop, it's going to print the class attendance for the value of count. So we're referencing a spot in the array using the count variable. And then we'll add it up. So with the first run through of this for loop, we're printing class attendance 0 because count is 0. At 0, which is that first spot in class attendance, it's a 12. So it prints a 12. Then we're going to, we're going to increase we're going to add the amount we just printed out to the total of odd classes. So odd total is equal to whatever odd total is right now, plus the additional 12 that we determined class attendance 0 was. And then after that, it moves, because it reached the end of the for loop, we increase count by 2. So instead of 0, count is now 2. And then we go through it again. Print class attendance 2 is 17, which it prints. And then we had the odd total was 12 at the end of the last loop. So it's odd total equals that 12 that it used to be, plus the value of count 2, which is 17. So it's those two together. And it just keeps going until it's run all the way through. After 5 loops, count will be 10, which is not less than 10. So it ends, and then it prints the total at the very end. So we have the odd classes. We have class 0, 2, 4, 6, and 8. So 0, 2, 4, 6, and 8. And then the total of that is 76. I see a little chat pop up. That's still discussing that question. Okay. All right. Now that we've discussed comprehensively the different pieces that we've looked at today, we're going to briefly go into object-oriented programming. So early programs in earlier programming languages just run through the whole code and they're done. As a result, if something needed to be run twice, that code would have to be in 2 different places unless it happened like back to back and you could use a loop. If it's more spaced out than that, then the code would have to be repeated. Many modern programming languages are object-oriented programming languages, which means that chunks of code can be reused. That you can give it a name and then reuse it. This saves programmers time because not only do they have, before they would have to retype the code that they made, but now they don't have to retype that code, and they can also more easily use code created by other programmers because they can just take a chunk and move it over. A line of code that is bundled together for reuse is called a function or a method. Both names mean the same thing. It's just different programming languages will use a different way to refer to it. The function has a name, and by using that name after it's been set up, you can quickly use that code in other parts of the program. A class is a collection of code that it contains both functions and variables. So we had the reusable functions that could be moved around. Now you have the classes, which contain functions, and then it can also contain variables, which are often but not always related to the functions that are in the class. It lets programmers group sets of related functions together and keep everything organized. Object-oriented programming lets programs get really complicated. We're not going to be working with any of them today, but it's good to know what some of these words mean because they are sometimes referenced in beginner coding material depending on what programming language is chosen. Some programming languages require you to have a main class that the program starts in, for example. Okay. Are there any further questions? This is the last time I'm calling for questions.
None at this time.
Great. Well, then we have some additional coding resources. The library has many resources to help you on your programming journey, including several books for both children and adults who want to get started in programming. We also have through LinkedIn Learning and Udemy, which you both can be accessed through the library. Both have several online courses related to the fundamentals of computer programming. They also have courses on popular programming languages with tutorials to help walk you through your first programs. There are also some other free online materials such as Khan Academy, code.org, and codeacademy.com. And then finally, the Plano Public Library Speaks podcast is available to listen and subscribe. Are there any final questions, guys?
No, we don't have any in the chat.
All right. A survey will pop up when you close out of the class. We appreciate your feedback and thank you for joining us today. All right. We're done unless there's any other questions. Okay, we're seeing people in the chat. So yes, and Meredith has put some links to LinkedIn Learning and Udemy stuff in the chat as well. Okay. Going to keep this open for a little bit longer to make sure that people have their chance to get those links out of the chat. Otherwise, thank you guys for coming. So this, I see that question in the chat about can we expect more in-depth explanation of the content in this training? This is meant to be more of an overview of different pieces of code that are often used. Right now, the best place to find more, if you were interested in the material that we covered today, some of those Udemy links or LinkedIn Learning courses will probably be very helpful to you. They will be, a beginning programming course would cover the same material we just covered, just a little more in detail as it goes. All right, we're going to go ahead and close the Zoom meeting. Thank you all very much for coming to today's program. And don't forget that the recording of the class will be available on YouTube later. You guys all have a great day.